This conference will now be recorded.
Yep. So now got it right. So now let's talk about inheritance. What is inheritance? Usually you have two classes. In that one class we can call it as parent. The other class we can call it as a child. The point here is if we try to derive the properties of parent to child or a superclass to subclass or a base class to derived class, that is what we call inheritances. Get my point, right? So deriving properties of a parent to child or superclass to subclass is nothing but we call it as or base to derivative. Anything is we call it as inheritance. Properties in sense nothing but in a class so far what did we declare? We had declared variables and methods. Those variables and methods of parent they get inherited to child. The advantage with this is whatever that is there in the parent, you don't need to declare them in the child again. So this what this is going to tell us, this will give us or this will provide reusability. Got it right? So that is the advantage of this in. So the advantage of inheritance is it avoids redundancy of code or repetition of code. So in programming, in this even in C, in C++, Java, or any language, we can avoid redundancy of code in different ways. So one fundamental way is with methods. If you declare methods, what method does is methods avoids redundancy or repetition of code. That is one way of avoiding the repetition of code. Then another way of avoiding repetition of code is this inheritance. Okay, of course, there is a small difference here. Of course, even though inheritance avoids repetition of code, here, what is it we are saying here? It avoids data redundancy. This is one question always people get confused, when between methods versus inheritance. So I'm just giving you a quick difference here. If you talk about methods, methods avoids code redundancy. What redundancy? Uh, methods avoid code redundancy. Okay, redundancy means code repetition. Otherwise, if you say redundancy, we can also call it as a repetition. Whereas when I talk about inheritance, no, what is the greatest advantage of inheritance is inheritance avoids data redundancy. You can see here the difference. What is difference between data redundancy and code redundancy? Code means it's like the business logic which we implement. It's that is code redundancy. Whereas data redundancy means it talks more about it's focused more on variable part. So we can reduce the declaration of variables number of times. That I will just explain with a small use case here. Yes, suppose it's just simple use case to understand how data redundancy happens in with inheritance. Sorry, how data redundancy is avoided with inheritance, not happens, is avoided with the inheritance. Suppose you have a class here. Okay, you have a class. That class have assume that class is something like a lion. Now you tell me what kind of properties does lion have? Because already we have discussed the properties of the concept of class and object. If lion is object, lion has properties and actions. Leave about actions. We don't need to talk about actions. Let's understand what properties this line has now. Line has name, line has color, line has age, line has gender. Okay, all this. You can take a few more if you want. Now, this is about line. Suppose take another animal which is like this wild animal. Take tiger, tiger. Now I want to declare a program for tiger to display details of tiger. Now even for tiger, what is it? 1 minute, I'm getting it. Okay, sorry guys. Suppose you take example of tiger. In the first example, I want to display details of lion. So I have all these details. In the second example, I want to display tiger. For lion, you have used this properties. Even for tiger, can we use this? Do we need same properties, right? Similar properties like it has name, it has color, it has age, it has gender, all this. Correct? You take another animal, a wild animal. You take some leopard. Suppose just an idea, leopard. Now I want to display details of leopard. Then you tell me what properties or attributes does leopard has. Even leopard might have this similar properties because all this falls under a category called animals. And most of the animals have a similar attributes. Of course, the name might change, or color might change, age might change, might or gender might change. But what is the point? These attributes will be same. So if you see here for leopard also, what is that? We need similar attributes like we need name, we need color, we need just an idea for it. Name, color, then age, and then gender, like this. Now when you look at these three objects, if I want to display lion, tiger, and leopard, then in this case, to declare lion details, I need four attributes for lion. For tiger, four attributes. For leopard, four attributes. Altogether, I need how many attributes here? 12 attributes. So, and now but these three objects or these three entities, lion, tiger, leopard, will fall under a category called animal. These are related objects. These are not different classes. They belong to a class called animal. It might be lion or tiger or leopard. Okay, I agree. That is they are different with their this thing. But these three objects or these three entities falls under a category called what is they calls under a class called animals. These are class of animals, class of birds, or class of humans. Okay, class of males. So that's what we call. Now we can, in this case, I need to declare 12 attributes. Still, I can avoid this repetition of code. You can see the same attributes which I declared for lion, I have declared for tiger. Whatever I have declared for tiger, I am declaring it for leopard. But what can I do? I can reduce this. I can simplify this. How? By taking inheritance. Now, if you see inheritance, we declare a common class called animals. And in this common class, what we do is we declare all the common properties which belongs to the animals, all animals, like like name, color, age, gender, something like this. Okay, and from this we inherit the subclasses. Subclasses means definitely they belong to a animal class. It might be cat, or it might be tiger, or it might be lion or leopard, whatever it is. They falls under the class called animals. You got it right? So now I'm just declaring all the common properties of animals in one class. Now I am declaring subclasses here. Like, assume that this subclass is a lion here. Okay. Again, I declare one more subclass. Okay. This is tiger. Another subclass, leopard. Okay, fine. Now I declare some subclasses and inherit these subclasses from this parent. This one. Now, if you see here, when I use this approach, here the top level class is called as a parent. This becomes a parent, and the bottom level class becomes a child here. Bottom level class becomes a child. Now, what is happening here? As it is an inheritance here, all the common properties of parents are declared in the of child. Sorry, of this child classes are declared in the parent animal. How many attributes I have declared here? If you look at the data in the previous discussion, when you look at number of attributes, for lion we have 4, for tiger we have 4, for leopard we have 4, but now we have moved all these common properties to this animal class. And how many declarations are there now? Variable declarations. We have just 4 data declarations. Now what's happening here? We avoided 8 declarations. Means what is it doing now here? It is avoiding the data redundancy or variable declarations. It is reducing the number of declarations or repeated variable declarations. Instead of going for 12 declarations, we just made it with 4 declarations, and we are avoiding for 8 more declarations. And this is reducing what? This approach is reducing the data redundancy. So this is the advantage of inheritance. Of course, you can do one thing. If you ask me a question, sir, can I declare subclass specific properties in the subclass itself? Yes. Suppose there is a sound method. Assume that there is a sound method. This sound method, lion makes some different sound, tiger makes some different sound, leopard makes some different sound, and we implement it as per their this thing, as per the entity. So when there are something specific to subclass, we declare them in the subclass. When something is common for all these subclasses, we put them in the parent. So what is the advantage of this? This avoids data redundancy. Anyhow, methods are still used here also in classes. So that is always there. For to avoid code redundancy, still we declare methods in a class. But this approach avoids data redundancy. That is the difference actually. Many people get confused. This is also one famous interview question. Got it right? If you ask people what is exact difference between methods and inheritance, not everyone are clear about it. Everyone will be working with the this inheritance all that, but still many people fail to explain the difference properly. Now I think it should be clear for both of for all of you, right? What is it? If it is a method, methods avoids code redundancy, whereas inheritance avoids data redundancy. Data means this variable stuff. Code means this logic and this all that. Whatever you declare inside method becomes code. Okay. Now we have discussed all this now. Just now, this diagram explains a lot of information. The one at the top of this hierarchy, we call it as a parent class. The one at the bottom, we call them as child classes. Parent class has all the common properties of children. And the child classes will inherit properties from parent, except private properties. Usually, I'm just explaining in a generic way. If any private properties are there in parent, they were not inherited to child. But public and protected properties can be inherited to child classes. We'll talk more on this with detailed example. It's nothing to worry about it. Okay. So this is the idea about inheritance here. This is a simple topic. We don't need to worry too much about it here. Now, if you look at it, the concept is simple. All common properties of subclasses are declared in a class called as parent or base or super. That is correct. The classes declared at bottom level are called as derived or subclass or child classes. And also, one more advantage with inheritance is we can break down your code into classes as per the this thing requirements, so that we can have a proper code maintenance. Code maintenance means that is a good standard programming practices. It inculcates or it provides standard programming practices. So that is the advantage of what guys inheritance here. Is it clear now? So one is it avoids data redundancy. Second one is what it also provides proper code maintenance. So, and then we have to talk about different types of inheritances. We have all this. We have 5 types. Not only in just Python, anywhere. If you talk about C, sorry, C++, you don't have inheritance. The C is purely functional. C++ are Java or C Sharp or Scala, whatever it is. Anywhere, the inheritance can be of 5 categories. But few types of languages supports only 3 different types of inheritances. It is what single, multi-level, and hierarchical. Some languages don't support multiple inheritance directly with classes like Java and C Sharp. Of course, they support in an indirect way, but not in a direct. Okay, but in Python we can do multiple inheritance. We don't have an issue or hybrid inheritance because it has its own way of simplifying things. Okay, so now in general we have 5 different types of inheritance. By default, we have 5 in all this language, C++, or this Python, or even in Java also. But the difference is we implement multiple inheritance or hybrid inheritance in a different way. But still that is there. I don't say we don't have inheritance completely. This multiple inheritance or hybrid, but we implement in a different way. But here we don't have that issue in Python. We are going to work with all the 5 types of inheritances. Okay? So now what is single inheritance? It's a simple concept. One class derived from one parent, or one child derived from one parent. That is single inheritance, as simple as that. One parent, one child. Deriving a class from another class, just one class, is nothing but single inheritance. And how do you do that inheritance in Python? All of us know now how to declare classes because we have seen many programs. We have implemented so many programs so far. We have done a detailed practice so far with classes and even with functions and different logics. Now we are doing this from December, if you remember. This is not we are not doing just from is that 1 month or 2 months. We had a lot of practice, if I'm not got it right. So first you need to declare a parent with all the common properties. Always we declare parent class first, and then we declare a child. While inheriting this parent to child, in this with this child class, you should declare a parenthesis, and within this parenthesis, you have to pass the parent class to them. Means this child, whatever class is there, it is trying to inherit this parent class. Means all the properties of this parent are inherited to this child. Got it right? Whatever properties are there in parent will get inherited to child if you apply this concept of inheritance. The only simple thing you have to do is declare a parent and declare all properties and methods, whatever you need in the parent, and declare a child and pass that parent to the child like this. And this will establish inheritance between parent and child. Got it right? So this is a simple syntax. You just take down the syntax. Then we'll do few examples, nothing more than that. Got it right? Now we'll do a small program. This is a requirement now. Declare a class parent with two properties A, B. You can set them in the same parent itself, set values for A, B, and just use a method to display these properties. Got it right? Are you following? So this is one. All of you are good now. This is one thing. Okay, am I audible, guys? Can you hear me? Are you able to hear me? Okay. We have some network problem going on. Okay. Take this requirement. Take a parent class with two properties A, B. Set them and print them. Take a child class B. Inherit A to B. You know the syntax. Through that syntax, inherit this A class to B class. Now, in this B class, take a variable C, instance variables, make them as instance. Okay. And take another method sum. In this sum, what I need is I want you to find the sum of two numbers. So the input variables you take it from parent class because already we have defined that in parent. You can directly use properties of parent to child. Now in this sum, you find sum of two numbers by directly using the variables of parent in the child and you print it directly. Now generally in inheritance, we create object for subclasses. Usually it is recommended to create objects for subclasses, not for parents. Why? If you create object for parent, there is nothing wrong in it. But actually we create objects for child. Why? A child class object can have access to parent class members as well. Through child class, I can also access members of parent. So if I create object for child, then automatically it will access properties of parent as well. So that is why in inheritance, it is recommended to create object for subclass. You got it right there. But anyhow, if you are interested to create object for parents, still you can do that. It's up to you. Okay? Got it right there? Is it clear or not? So test this now. Try this example. Do this yourself. This is simple. This is very basic level examples. Just to understand quickly how inheritance works. Once finished, just confirm once you are done. Then I will just run the code and just have a quick walk through that. Then we will switch to the next type of inheritance. So there's a single inheritance where you have one parent and one child. That's single. Once done, just confirm, sir. Then I will also just quickly run, and then we will switch to next type of inheritance. But if you get a clear idea about single inheritance, other inheritances are almost same, similar to this thing. We have a few differences, and we see that, and we try to complete this today. Okay. All of you are clear with this? Is it clear for everyone, sir? Understood? Or any questions on that? Understood, sir? All of you? All of you are done? So we'll just see the example. So just to show you the inheritance concept, okay, I'm using this. You can go use Python. You can run with anything, sir. Any idle is fine. PyCharm or idle. Even Anaconda is also fine. You can do with Spider as well. Just a minute. Okay. We have tested all this. So I'm taking a class parent. In this, I am declaring two instance variables. So what is that? First of all, a method set values, and then two variables inside that instance variables. And I am using what is that? I am directly initializing them here. Self dot a equal to 10. You can use. You can also input from keyboard if you wish. You can input from keyboard. That's up to you. Okay. Then another one self dot b equal to 20. So we have defined that, and then one more the of data. Then just I'm printing these values here. I'm not doing anything else. So a is comma A. Similarly, do it for B also, sir. B is comma B. So, okay. Then you take this is parent. What did I do in the parent? It's a very simple. We just declared two methods and two instance variables with A and B as the instance variables, and one method to initialize them and one method just to print them. Okay, and then here I should say self dot here, right? Self dot because instance variables we know, right? Wherever instance variable is there, there we have to apply self. Wherever instance method is there, there we have to use this self keyword with that method. All of you know the type of, right? Now you declare one more subclass, class B, and inherit parent. You know, right? Like this. So in this parenthesis, put this A with the B class. It means this when you look at this, it means we are inheriting A class to B class. Now you see, I declare a method def. I take direct sum method, sum. Okay. Now inside this, I say self dot C equal to self dot A plus self dot B. If I say self dot C means we are declaring it as instance variable. If we directly declare it as C means it is local variable. You know the difference, right? So that's the point. Okay. Now print that C in the same class itself, same method itself. Print of the sum is, let's simply say sum is comma self dot. Now what do you do right now? Create an object for, now I have, this is how we have to prepare or create parent and child classes. Now what should I do, sir? I should create object for subclass. How do I do? You know, right? We have already had a discussion. Simply it's B space B, then B dot. Now if you see, I created object for B class. Okay, but what I'm going to do? First, I'm going to call set values method on B object. The method of pairing, I call on B reference. I say that here B dot set values, and then B dot get data, and then B dot sum. B dot what? Sum. If you look at this code, this itself will give you a clear idea. What is that time? This variables A and B, I didn't declare in the B class, but I am using them directly in the B as if they were declared in the B itself. But in fact, these variables are declared in the parent, but not in the child class. But I am using them directly in the child itself. And this is possible because of inheritance. If you remove this inheritance with B, immediately you can see an error here. If I try to run this program, it will show errors here with this A and B. It will show errors with these two methods as well. Suppose let me run this code, you get an idea. Let's see here now. We got errors here. Clearly, it's saying what is it? Indentation. First thing is unindent does not match any outer indent level. But let me fix it first. Let me fix the indentation. So this is one issue. That is fine now. We fixed it. Can you see there now? First, with B attribute, with this B object, it's saying it doesn't have method set values. But suppose if I do the inheritance, if I try to put this A here, and then if I try to run this time, to our surprise, we have data here. Okay, we have a data here. Means what? If there is a relation between a parent to child, then we can have access to the properties of parent to child. Suppose you remove this, then these two are different classes. A is different, B is different. There is no relation. Now, when we don't have that relation, this parent, this child cannot have access to parent properties. Or when two classes are different, when there is no relation exists between two classes. See, in inheritance, in this object oriented programming, we create relation with inheritance. Inheritance is the proper way of creating relationship between two classes, and that relation we call it as easy relation. We call it as inheritance is always called as a easy relation. I'll just write here. Okay, what is it? The relation here we can call it as a is a relation. These are all common terminologies, sir. Technical words. Is a relation. What is a relation? Suppose when two classes are there, we can say A is a parent of B. Suppose when we have inheritance, I can say A is a parent of B class, or B is a child of B is a child of A class. And we technically denote. Suppose you go to some UML diagrams, all that. So this technical terminologies are very useful to you while creating relationship between, when you create entity relationship diagrams. Okay, this is very useful to you. Okay, because this talks about when you say is a relation, then you should remember what is that inheritance. When you say has a relation, there is one more relation called, we call it as has a relation. Means we don't directly use this, we don't use this use a and has a in the code, but with the kind of relationship. Suppose if you have inheritance, we assume that is a relation, and has a instance, there is another way of having access of members one class to another class, that is with has a. In that case, you don't have a relationship between these two with inheritance, between two classes with inheritance. But if it is a has a relation, what do we do here is we create object of one class in another class. Of course, in the methods or in the instance scope, we class objects of one class in another class, and with that object, we try to access members of that class in the another class. If we try to access properties of a class in another class through its object, it is has a relation. And if you try to access properties of one class to another class through this inheritance, it's a is a relation. Now we are getting a quick idea about is a relation here. We will also see a small example about has a relation as well after this. Okay, so what this clarity here now? Is it clear to all of you, sir? Tell me. Now, what is the point finally? This is the idea about what is that inheritance. Single inheritance. One parent, one child. Understood, no? Yes or no, sir? How about others? Is it clear for everyone? What kind of relationship is this, sir? What kind of relationship is inheritance, sir? Is it is a relation? Got it right. Now, how does has a relation work? I will show the example here itself. So this is the example. All of you are clear, right? By looking at the code itself, we can understand what is that. We are accessing members of parent directly in the child, the variables of parent of A class in the child class B. We can call B as child only when we inherit A. Second thing, on B reference, you are calling methods of A. If you see set values and get data, they are not part of B class. But these methods of A, we are calling on the object of B, and this is possible because of inheritance. Otherwise, it's not possible. And it is applicable even from real life. If father has a car, son can use that. Got it right? If mother has some other jewelry, daughter can use that. Like that. If father has crores of property, son can use that. Got it right? If father has a servant, the same servant can come and work in your house as well, like that. Just a quick, thinking to analyze. Got it right? This is idea about this one. Now, quickly let us have a quick idea about has the relation, how this works in programming. Might be as you have a doubt there. Here itself, I am just explaining the has a relation so that you understand different types of relations which exist in object-oriented programming. Usually, we have two types. One is a, the other one is has a. When I say is a, you should remember inheritance. But sir, when I say has a, it's not inheritance. These two objects are totally different, and we don't have inheritance here. Of course, remove this. Okay, how do we have access from A to B here? One advantage, the one way is like this, like we can call it like this. How? First, you create object for A class in B class. How do we create? The same way how we have done in the main scope, except the code which we write in the classes in the methods, all other statements which we directly write in the in the scope are part of which method? Main method. All the statements which we write outside classes, outside methods, this entire code goes into main method. You might ask me a question, do you have a main in Python? Yes. In any language, in every language main exists. I'm not sure about COBOL, whether COBOL has main method or not. Madhu, do you have main in COBOL? Main method.
Oh, it is a kind of a procedure language. It's a procedure division. There are divisions. So there
Hmm.
is a division called the procedure division. So the always cursor, I mean that execution will start from procedure division.
Okay, okay. So like this, like in other traditional languages, it is little different. Correct, right?
Yeah, yeah.
But in all these languages, starting from C, C++, Java, even in Python, I will show you in a debug mode that always execution starts with main method. Even in Python, maybe if you directly declare statements outside class or outside function, these statements goes into main method. So that is fine. We'll talk about it. Okay. But now coming back to the has a relation. Now I want to have access to properties of A class and B class. Now both are different classes. How can I access members of A and B? Then I should create object for A and B here in the method here, like this. Now I can say something like this, sir. How instead of self dot A here, I can say A dot A and A dot B like this. Even when you say A dot A and A dot B, it is as simple as calling with self dot A and self dot B, sir. I told you, self is something like, it is an object which holds address of same class itself. Okay, it holds the address of a same class. So self is a kind of reference. It's called implicit reference. But here A is explicit reference. If you say self dot A or self dot B or A dot A or A dot B, the concept, the approach is same, but the way we are trying to access members is a bit different. That's all. But in both cases, we are trying to access members through its object. That's it, that object of that class. You get my point? So that is the point here. So now you can just self dot save, and what you can do now, you can run it again. So nothing to worry. I removed calling, which one? I removed calling set values and get data here. But you can do one thing. You should do one thing. Sorry. Here, once after you create a class object, you know very well, we must and should call this set values method. And without calling this method, you know very well, we cannot create these variables inside the object of that a class. So here, if this object should have these variables a and b, if they must be created, then you must call this method at any cost. Otherwise, you get an error. Unidentified variable A, unidentified variable B, or object A doesn't have attribute A or attribute B, something like that. So what should I do now? I should say A dot set values. Okay, this is very important. Now what did I do? I create an object for A class in B class. If you see, I'm creating object of A in B here. Then I'm calling this set values method here. I'm calling this here. Okay, now once you call set value, you can have access to variables like this A dot A or A dot B. This will work, right? But without calling set values, if you do this, it leads to an error. Got it, right? Because these variables A and B are created inside the object of A only when you call the set values method. You understand my point? So what do you do right now? Finally, this is fine now. I can directly run some function, or here I can also call. You want to see what data is there in A object, then you can call get data here itself. And after that, you can carry out your business logic and then you can print the result. And this relation where you try to create object of a parent and child, this is, you can call this as a hazard relation. Got it, right? Now, this B has a object and even A can have B object. When you try to create it like this kind of relationships, we call it as hazard relation. Got it, right? You understand it, sir? And I should do one thing here also. What should I do? Self dot. If I want this to be part of B object, I should say self dot A equal to A. Got it, right, sir? And then again, what is that? Here also, let me just here also, what is that I should see? If I want to be part of a B object, otherwise it becomes local, sir. Local variable. If I want to make it a standard has a relation, then I should say self dot A dot set values. Let's try in this way. And then self dot A dot get data. When you apply self, then it is a proper has a relation. If otherwise it is a local, even though you create object in the method, it becomes a local variable. Then I cannot say it as a has a relation. Has a relation is like this, sir. I'll just show it in a diagram. Let me explain with the diagram. One minute, I'll show you. Has a relation exists like this. Okay. I have an object like this. Assume that. Okay. Take two objects. Apple. The other one is just an idea. It doesn't make. See, don't worry about the sense here. This is pineapple, or you can take it as some other jackfruit. Okay, call it as a jackfruit. Now, in this jackfruit, I try to keep this apple object. What I would do, I try to create apple object in jackfruit. See here, inside this, inside jackfruit, I create an object of an apple. This is apple object. Okay, or otherwise even you can type here also. Now what's happening here? This is has a relation. What is it? Jackfruit has a apple. Inside jackfruit, I have what? Apple object. Got it, right? This is called what relation? Has a relation. You get my point? Right. So, or otherwise, the other way of keeping it like is like this. The other way is like, might be you can just take some this thing here. And the reference of this this might be assumed that you created an object this object has some reference, right? Yeah, Apple has some reference. Apple address might be some 100 like this. Now, and here this is the reference variable of Apple, which you created in Jackfruit. You create inside Jackfruit class like this, method like this, some self dot, okay, some f equal to, you say Apple like this. Just an idea for you. And you do this method of Jackfruit, some method of Jack. Assume that this is something like the of some set Apple, which I am going to create it in Jackfruit. This is in Jackfruit class. And I have what object now? I have created object for Apple here. Now what is going to happen now? First, the Apple object is created. It won't exist directly in the same Jackfruit. First, it is created like this. And the reference of this one, usually in OOP, what happens is reference of this Apple is copied to this here. This 100 is stored into this. This is self dot f. This becomes f. 1 minute. This block becomes f. I'm explaining here. Okay, this is f. And now here that 100 is stored. Means what f is doing now? F is referring to the Apple object from Jackfruit. Means what is this? Jackfruit has a apple. This relation is called has a apple. Got my point? If it is inheritance, inheritance will be totally different. Do you understand this, sir? All of you get this point now? Can I get yes or no from you? And that is what this is. When I create it like this, A object inside B, it means like we are creating a, assume that apple as a, what is that, A, and jackfruit as B. What's happening now? That A object is created into B like this. Means the reference of apple will exist in this B object. You get my point? Can I get an yes or no from you, sir? Still, I think I didn't get any response from you, sir. Is it clear or not? Okay, now that is what this. Let me run this, sir, whether this works or not, because we just done a workaround here. And, A is not defined. Let us just self dot. What should I do now here? Here might be
Oh, that is also self dot a
yeah,
plus. Yeah.
going self dot a dot a, right? Self dot a dot b. Now this should work, right, Madhu?
Yeah, it works.
This is perfect has a relation. This is perfect has a relation. Do you understand this, sir? So this is a very good example of how has a relation works. Yeah, having one class object in another class is nothing but what is that? Has a relation. Like I told you right just now, I have shown with an examples like that. Like car has a engine, you know, right? Engine is first developed separately and car is separated. Sorry, car is developed separate. But what happens? They will bring that engine and fit it into the car. Now what do we say? Car has a engine. Got it right? Like that. Right. So what is it now? So you can just test this code, sir. All of you. I think if it is clear for all of you, what do you do, sir? Please test it. So having object of one class in another class is known as a relation. You can test it, sir. Please test this code. And if you have any doubts, please ask. You can test this here. Once it is completed, please confirm, sir. So this is about inheritance, is a relation and has a relation. Okay. Next one. Multi-level inheritance. So I told you, once we are comfortable with one type of inheritance, and this is almost same for all other different types, but with some few changes. Multi-level is an extension to if you do not use self, then they becomes local variables. Okay. So anyhow, you can go. All these sessions are uploaded in YouTube. You can go through that after the class. Okay. So that will give you a clear idea. So now this is an extension to single inheritance. It's like grandfather to father and father to child and child to grandchild and grandchild to grandchild. It's something like that. Multi-level means deriving a subclass from a superclass. And again from that subclass you derive another subclass and so on. This continues like our generations. generation after the generation. It keeps going on like that. That's what we call multi-level inheritance, like this. Usually, as per UML, this arrow mark should point to the no to the upper side of this one. Usually, people I see sometimes keep giving arrow mark to the bottom. That is not correct. If B is child and A is parent, this arrow mark should be upper arrow mark between A and B. That is a perfect UML diagram. Okay? So you can see it anywhere. If arrow mark is pointing to the top means it is a parent, and the bottom one is a child. Like if it is reverse means then B is child and A is sorry, B will become parent and A will become child, like that. To whichever the class arrow mark is pointing, that is always a parent. Keep in mind. Okay? Now in multi-level inheritance, a bottom level class, a grandchild have access to all its parents' classes, all its top level classes. Like like if you talk about Naga Chaitanya, he has properties. He will have access to properties of his father Nagarjuna and also as well as Nageshwara. If Nageshwara father's properties were there, even that can be acquired by Naga Chaitanya. Just an idea. So a bottom level class has access to all top level classes except private properties. Of course, if if a father or grandfather has something private, purely private, they are not accessible to you. But public and protected properties are accessible. Okay. So that is the idea about the multi-level inheritance. What you do is take a small example. Let's extend this previous program. The previous program, what did we do? We declare a parent like this AB, and then set values and display. Use the same class and B. And in the B class, in the previous example, we find some and take one more class C, extend it from B, and in the B class, try to implement you do the product. Now, how do you do the product in C class? Use the properties of AB from A class and C from B class and do product of all those three variables in the C class. And now if you create object for C, C can have access to methods of B as well as methods of A and variables of B as well as variables of A. Through C object, you can have access to all that. If you wish to create object for B and C, it's up to you, sir. But if we just create object for C, it's sufficient for us. Okay. So what do you do right now? Just take this example, do it, complete it. Okay, finish this. Take some time, some 2 or 3 minutes or 5 minutes. Finish this. This is idea about multi-level inheritance. Here it will go level by level, but we restrict usually in a real time. We don't take too many levels, so we try to reduce number of levels as possible so that it will be effective and efficient. That is also important. Okay? So please develop a program for this requirement just to understand how multi-level inheritance works in this object-oriented program. Okay? Right. So I have pasted all that notes, whatever you have done today. Anyhow, I will share the file as well if you want. This is already there in GitHub. Just for filing notes, I am sharing this with you. Okay. Okay. Uh, just confirm, sir, if you are done with this. I will show you how to do this. There is nothing you can see here in this code. We declare class A with set values, and we have defined two variables there, instance variables, and assigned with some values. And then we use display to print those instance variables, and then inheriting B from A, and we find sum by using variables of B in of A class in B here, not B of A class A variables in B. Then we print it, and we try to inherit C from B. Now C has access to properties of B as well as A. Now if you see A and B, we are accessing from A class, and this C from B class, this one, and we are finding out some sum here, some product here in the C class with the method null, and we are printing result. Now I have created object for C and try to call methods of all the methods from A class to C class. So first you should call set values. Display is optional. If you don't call display, nothing happens. But sum is mandatory, and then you have to do multiplication. Okay. Right now, I just quickly test this code just to show you like the output of this program. That's all. Okay. Now go to the run, then say, you can see the output here. Can you see? 10, 20. This is from A class, 30 is from B class after doing sum of AB, and 6000 is from C class. 30 is from B and 6000 is from C. This is a product of ABC, 10, 20, and 30. You get this, sir, all of you? This is the idea about multi-level inheritance. So we can quickly finish remaining inheritances. Okay, but I'm going to stop session here today. We have some work here. So we'll finish off tomorrow this one, and also difference between a static method versus a class method, that is also there. First I will finish this and then go back to that discussion. Tomorrow we'll close off all this, and then I'll switch to polymorphism. So probably we are almost ending to the OOP, object oriented programming. Now we have done core Python. We are almost at the end of advanced Python. Then we will see few more interesting topics here. That is regular expressions as well as exception handling, and then also connecting to the database. We look after all that, and then probably we will be ending this with here. Okay. Then we'll start with data science fundamentals like analytical Python, NumPy, pandas, all that. Okay. That's how we proceed. Okay. Is it clear for all of you? All of you are good, sir. Okay, guys. I'll stop here. Today there is some work to me for me. We can do one thing tomorrow. Is it comfortable for you if we do this session at 5 o'clock, not at 7? Is it fine? 5 p.m. is fine for all of you. 5 or 4 will be 4. Okay then. Yeah. So we'll do one thing then. Tomorrow, probably we connect by 5 o'clock. Okay. Clear? Okay, sir. Thank you. Happy weekend. See you guys.